So let us start with this simple example where there are capacitors given this manner. This is 3 mu f, 3 mu f, say this is also 3 mu f and 3 mu f. Your problem is to find equivalent capacitance between A and B. See, the method of finding equivalent capacitance involves one immediate step. You have to imagine that if you don't connect it like this, imagine that there is a cell connected between 2 points A and B, whose equivalent capacitance you are going to find. This is the simplest sum, but I tell you to do this just to keep this concept in your mind. Then charge distribution plus Q minus Q, and this big Q1. Although symmetry is there, you can assume that this is Q by 2 minus Q by 2, Q by 2 here, minus Q by 2 here. Then again, there will be Q and minus Q. So it is quite obvious that these two capacitors, they have the same potential between 2 points. I mean, between the positive and the negative plate. So they will be in parallel combination. In parallel combination, their equivalent capacitance is going to be 3 plus 3, that is 6 mu f. Now the circuit reduced to this form. There is one 3 mu f, 6 mu f, and another 3 mu f between A and B. So this is 6 mu f, and this one is also 3 mu f. So C equivalent will be, 1 by C equivalent will be 1 by 3, 1 by 6, 1 by 3. 6 is the LCM, so there will be 2 plus 1 plus 2. C equivalent is reciprocal of RHS, 6 by 5, 1.2 microfarad. Just to replace these capacitors by this single capacitor, the concept is that it will assume the same amount of charge. That's why it is equivalent capacitance. Now let us start with this one, where capacitors are taken this manner. Your problem is to find equivalent capacitance between these 2 points, A and B. This has capacitance 4 mu f. And one thing I did not mention, the plates are of same size and same distance is maintained. Okay? So that they have the same capacitance over there. Now to find the equivalent capacitance between A and B, again you go by the same connection that there will be a cell connected between 2 points A and B. Take the cell anywhere, but they must be connected between A and B. So the charge will be here as Q1, this is minus Q1, this is Q2, minus Q2, same charge Q2 minus Q2, Q2 minus Q2. They are getting same charge. They are in series combination. And the condition of taking charge Q1 plus Q2 from the positive cell is that you have to meet the negative terminal with the same 2 negative charges. That is same 2 positive charges. That's Q1 plus Q2. It means whatever amount of charge you have drawn from the cell, same charge will be given back. So now it is obvious that this capacitor is in parallel with these three capacitors. So if you break the circuit, it will be like this. So between 2 points, there is 4 mu f this way. Here it is 4 mu f, 4 mu f, and again 4 mu f. So equivalent capacitance 1 by CAB will be what? That is 1 by 4 plus, what is the equivalent capacitance of these three? That is 1 by C dashed, 1 by 4, 1 by 4, 1 by 4. C by 4. So C dash going to be 4 by 3. So this is 1 by 4 by 3. So 1 by 4 plus 3 by 4. It is 1 microfarad. So if you take the reciprocal, then also it will be 1 microfarad. Okay. So these are two simple questions I have discussed so far. Now,
স্যার লাস্টে ওই দুটো তো প্যারালালে আছে না, তো অ্যাড হবে না?
1 by CAB, yes, yes. CAB will be just added over there. Sorry. So there in parallel combination, CAB will be equal to just sum of these two. CAB will be 4 plus 4 by 3, 12 and 16 by 3 microfarad. Okay. Now, this one, where there are three capacitors in this form. This is 3 mu f, 3 mu f, 3 mu f again, and take different also. Same type of calculation will be there. Join these by a connecting wire. These 2 points. You have to find the equivalent capacitance between 2 points A and B. Okay. So how to get it? To find the equivalent capacitance between 2 points A and B, again, we mentally put a cell between 2 points A and B. If you don't put, there is no problem, but imagine there is a cell between 2 points A and B always. Now, from this positive terminal, what kind of charge this one receives? This will get plus, minus. This will get plus, minus. No, this is also plus because they are connected to this positive terminal of the cell. And these two ends, these are connected to the negative terminal. This part connected to negative. So here negative already there. This part will be negative. This part also negative. Understood? So these three capacitors are like this. They are getting charges different, but PD between these 2 points, because the negative terminal, PD between these 2 points, you name the points here. This is C and this is D. VAD is equal to VCD. Okay. And also that VCB also has the same potential because this point A and C are common, B and D also common. So across these three capacitors, the potential remain the same. As potential remain the same, so we can treat them as parallel combination. This is C mu f, this one C mu f, this one also 3 mu f between A and B. C mu F, C mu F, they are in parallel combination. So C equivalent going to be 3 plus C plus C microfarad. This will be equal to 9 microfarad. All right. Now let us go for next kind of sums. That this is going to be an infinite loop. So number 4 is going to be capacitance of an infinite loop. But we'll do it without using the loop rule, that KCL or KVL, Kirchhoff's that point rule and the junction rule and the mesh rule, that we are not going to apply here. So the circuit given this manner, infinite loop given this way, this is 2 microfarad. This is 1 microfarad. And this part repeats. Continues this manner. This is 1, again 2. This is infinite loop, I told you. So it continues this manner. Again, this will come here, 1 mu F. It continues this way, 1 mu F only. These are all 1 mu F. And this is 2 mu F. We have to find equivalent capacitance between 2 points A and B. So what we'll do here, we'll just use one simple concept, that from the whole circuit, if we keep this circuit separated, then the remaining circuit here will remain infinite loop only. These two are separated. This is a loop, this is another loop. This loop, it is same as before. Okay? This circuit is different from there. If we know the equivalent capacitance of this part, then we can find equivalent capacitance between A and B, because then 2 mu F is going to be in series combination with the equivalent capacitance of this part. Now, the original circuit has capacitance C only. So this one also has capacitance C. If we remove this part, then also equivalent capacitance will remain the same. So you start this manner, let equivalent capacitance CAB equal to C only. If we take these 2 points C and D, then obviously VCD is also C. There is no problem in this understanding, because you have taken equivalent capacitance of the whole circuit as C. So if this part C, that I mean right part is C, the whole circuit C, then we can draw the equivalent circuit here by taking this one equal to C. The circuit going to be like this. This part is equivalent capacitance C only. This is 1 mu F. This one C mu F, 2 mu F, and this is A and B. 1 mu F here. All right, C and B there, but their equivalent capacitance we have taken C mu F, so it will remain the same, C only. Now, between A and B equivalent capacitance we can find easily, because for this part they're in series combination. They're in series combination. So 1 by VCD, this is going to be 1 by 2 plus 1 by C, 2C, C plus 2. So VCD equal to 2C by C plus 2. Now draw the circuit once more. VCD, no, this is actually 1 by V, I mean for this part, VACD, better to say, between A and D via the point C. 1 by VCD, VACD we got. So this part we'll put here as 2C by C plus 2, and this is 1 mu, obviously. Now they're in parallel combination. So CAB will be what? This is not V. Please keep this in your mind. This is capacitance CACD. Now CAB is what? Between A and B capacitance, they are in parallel combination. Just sum up these two microfarads. So therefore, CAB is C plus 2 plus 2C microfarad. Now, this CAB you have assumed C only, as CAB equal to C, therefore C equal to 3C plus 2 divided by C plus 2. C square plus 2C, therefore take on the left hand side C minus 2 into C plus 1, 0, can't be negative, so C equal to 2. So equivalent capacitance of the loop is equal to 2 only. Now let us consider loop of, I mean, a loop where many capacitors are taken this manner. Number 5. We are taking a capacitor C over there. Then we are taking 2 capacitors, same value. Then we are taking 4 capacitors. Then we are taking 8 capacitors, this manner. This is also going to be infinite. Okay? Infinite loop. All are equal to C. Find equivalent capacitance between A and B. This is not a difficult one and little bit mathematical. So here capacitance is C only. Here how much? There in series combination C by 2. Here how much? C by 4. Next one will be C by 8 and so on. So C equivalent CAB, C plus C by 2, C by 4, C by 8 up to infinity. Infinite GP sum, you know, A by 1 minus R. If the series is AR square up to infinity, then summation of this infinite series is A by 1 minus R. So there will be C by 1 minus 1 by 2. Answer is 2C. Clear? Hope you have understood. Now, we are going to discuss capacitance of adjacent capacitors, adjacent plates, better to say. Capacitance of adjacent plates. If many plates are given this manner, kept side by side like this, they are all equidistant, they are of same size, you have taken n plates this manner. How to find the equivalent capacitance between these 2 points, A and B? Whatever you take, they will be in series combination, isn't it? And how many capacitors will be formed between 1 and 2? The plate 1 and 2, one capacitor of capacitance C, say, and the last one is also C. How many will be there? N minus 1 capacitors will be formed. If 3 plates are there, 2 capacitors. N minus 1 capacitors are formed. 1, 2, 3, 4. Because n minus 1th and nth, there will be n minus 1th capacitor. So 1 by CAB, 1 by C. Now the question is, if you maintain the series combination like this, between these two, like this, if you continue, then series combination 1 by CAB will be 1 by C, 1 by C, 1 by C like this. This will be n minus 1 by C. So CAB equal to C divided by n minus 1. Okay? But plates will not be given in this manner always. Plates may be given this way also. I'm just taking this example.
Sir, would it be possible to show the last one again, please?
Yes, yes. Yes.
Yes, sir. Thank you.
This manner they are connected. These are plates. How to find CAB, that equivalent capacitance between 2 points A and B? Whenever this kind of problems are there, then you always name the plates. This plate 1, okay? Outside one you are not numbering. This is 2, 3, and 4. These 4 plates are there. So between, you imagine that there is a battery connected between 2 points A and B. Then charge distribution will be there. These 2 and 4, they are connected to negative terminal. These 2 are connected to positive terminal. So, and those plates are of equal area. The way we have taken before, they are of equal area and plates are of equal area and equidistant. Then you have to find equivalent capacitance between them. After naming this, those points 1 and 3, they are actually the point E. So you'll be taking these 2 points together, 1 and 3. These 2 points 2 and 4, actually the point B. So you take 2 and 4 here. Okay? Connection you have done alternately. This manner, if it continues, then I'll tell you a very special case in compared to this one. If connection was made here like this, then C by n minus 1. The connection I'm going to make now, alternative plates are connected to the positive terminal. Okay, let me solve this problem first. Between 1 and 2, this will get positive charge. You can see in the diagram. This will get negative. This is positive, and this is negative. Okay? So between now, we are going to find the presence of capacitance over there. Where? Between 1 and 2, it will be 1 capacitor. Between 1 and 2, there is a capacitor. Between 2 and 3, there is a capacitor. Between these 2 and 3, there is a capacitor. And between 3 and 4, also there is a capacitor. Okay? So it is actually going to be parallel combination of 3 capacitors. Okay? These 2 points, A and B only. So CAB will be what? This is equal to 3C. Now suppose this connection is made in such a manner that all alternate plates are connected to one terminal of the battery. So if n plates are taken side by side and alternate plates are connected with positive terminal okay, like you have connected 1, 3, 5, 7, they are connected to positive terminal, and even numbered plates are connected to negative terminal. Also, other alternative plates are connected with negative terminal of a battery. Then CAB will be what? In that case, CAB will be n minus 1 into C. They will be in parallel combination. That's why if 4 plates are there, you put n equal to 4. If n plates are there, what have you seen? CAB equal to n minus 1 into C. For n equal to 4, CAB will be 4 minus 1 into C, that is equal to CC. Clear? Hope you have understood. Now, let us go for a few more sums of this kind, because capacitance of these adjacent plates, when you consider, many questions may be very confusing for you. this is one of them. How does it come? I hope I have explained in details. Now, we are going to consider another. Now, you have to find the capacitance between the points A and B. So, let us go by the same concept. We imagine that these two are connected with the battery. A with positive terminal, B with the negative terminal. This plate, we can name, again we can name this. This is 1, this plate is 2, 3 and 4. External plate you never number. In this process, external plates will not number. So external plate will assume that no charge is there, it is 0 only. Whatever charge appears here, that will be by induction here. If this is positive, this will be negative, and this is also negative. This part is positive. Okay. There is no other case here. This is the charge distribution. So how many capacitors are formed over there? There will be 2 capacitors only. Between 1 and 2, 1 capacitor. You name the same manner. You take it here. That is 1, 4, and this one 2, 3. How many capacitors? This is 1, and this is the other one. Between 2 negative terminals, no capacitor can be there. So situation will be like this: between 1 and 2, 1 capacitor, and between 3 and 4, the other capacitor. So this one C, this one C, therefore C equivalent or CAB, whatever you say, this is going to be 2C1. Hope you have understood equivalent capacitance between the 2 points A and B. Okay. Now let's go for another one here. I'm not taking flat one. Plates are represented by the lines here. Here distance is D only. I mean, this is D, this is D, this one also D. Maybe confused, that's why I told you. Your problem is to find the equivalent capacitance between 2 points A and B. What method should I follow here? Again, you connect them by a battery. When you imagine that there is a battery connection, always, and battery is responsible for providing charge, then it's very easy to understand for you. I mean, the plate you take from here, otherwise you may be confused. Like this, the plates are like this. This is 1, plate 2, plate 3, and this is plate 4. Okay? Find equivalent capacitance between A and B. See, through the positive terminal, this will get positive charge only. This one by induction, no connection is there, but induced charge will be there. Negative. This is also negative. All right. And here you have connected with the negative terminal. So if this is negative, it will be inducing plus charge over. This is not external. I told you not to mark external one. This is not external one. You can take this point as 4 and this one as 5. Okay. What kind of charge does it get? This is also negative. All right. Now, to find the equivalent capacitance between 2 points A and B, you first name all these things. This point you name as the point C. So between the points A and C, there will be a capacitor. Okay? Between the point A and C, there will be another capacitor, but they will be in parallel combination. This one C, this one C. These two have taken, no? Because this is positive, negative. One capacitor is formed this way, the other one formed this way. They must be in parallel combination. That's what we have taken. This point is A, and this point we have taken C. What does this point go then? Between C and B, one capacitor is formed. You have to take that. Between C and B, another capacitor is there. So this is the problem. Battery was in this manner. It has distributed charges coming this way. Okay. So you can easily find this is not capacitor. This is the battery we have used. Between C and C, one is there. I mean, between A and C, two are there, and between C and the other one there. So what is equivalent capacitance here? Capacitance between these 2 points, CAC will be equal to 2C, and this will be parallel. So 1 by CAB will be equal to 1 by 2C plus 1 by C. 2C is the LCM. So 1 plus 2, CAB will be equal to 2C by C. Hope you have understood. There is no problem in understanding this. I am going for another bit complicated sum here in this category. Okay? That is done. Now let us take another example. It may look bit complicated. Just let me draw it here. So these two connect. Okay, you have to find the equivalent capacitance between 2 points A and B. Okay, we have to go for charge distribution here. Whereas these two plates are connected with positive terminal, so there will be plus charge only, plus, plus, plus. Like this, it will induce negative charge here and positive charge on the other side. Okay, and here minus and this one plus, same charge, because no battery connection is there. So charge on it will be 0, net charge on it also will be 0, but not on this. It will have negative charges over there. And here again, this is negative and this one positive. Okay. To find the equivalent capacitance between 2 points A and B, don't forget to connect a battery over there. It is there. Assume. And this is the positive terminal of battery, and this one is the negative terminal. Now, you are going to name this point. This point, if you name, then these two plates are named already. This one not done, so we must do it first. Then we go for arranging the plates of capacitor between the given points. You can see that between A and D, there is a capacitor, plus minus, no? So this point is A, this one D, between A and D, one capacitor is there. And between D and C, between D and C, there is a capacitor. Between the point C and the point D. So it is better you take the point D here. So this point is D and this one A. With A, there is a capacitance between, there is a capacitor between A and the point D. That we have taken. Now between A and C also it is there. See, this is positive, this is negative. So draw it there. Then between C and D, one capacitor is there. Between this point BC, between C and D, there is a capacitor. Okay. Then between C and B, this is positive, this is negative. C remains positive end. So there is a capacitor. That is between C and B. Clear? Hope you have understood. So with A, as it is connected to positive terminal, then this charge will be positive, positive, this is also positive. Okay, this is negative 1. The same manner, plus here, minus here. This is minus, this plus, this is plus. So this is again plus and this is minus. Now, how to connect the points over there between the equivalent capacitance? How to calculate there? That between A and D, there is a capacitor of capacitance C. This one C, this one, because they have all these capacitors, they have the same plate area and same distance between the two plates. So between A and D, the capacitor, you can take this manner, and with this capacitor, C is in series combination. So you take it this manner. Okay. Now between A and C, there is another one. Take it like this. So this is A. Okay. And this is the point B. Clear? This is the point B. Hope you have understood, because between A and D, there is one. This is D, no? This point is D. This capacitor is there. This one is also there. Between A and D, and then between D and C. That only I have taken. This side is positive, positive, negative here, plus, plus. This is plus. This one is minus. And this is plus. This is minus. Now, these two capacitors are in series combination. So, what is the equivalent capacitance over there? This one has value C. C into C divided by C plus C. This is C by 2. This one C. So, the equivalent capacitance, this thing is C by 2. This one C. And this one the point B, A. So now add these two capacitors. C by 2 plus C is CC by 2, and this C is in series combination. So 1 by CAB. This is the capacitance of this portion. 1 by CC by 2 plus 1 by C. So it is 2 by CC plus 1 by C. This will be 2 plus 3. So the value of CAB is going to be 3C by 5. Hope you have understood.